According to the National Electrical Code, NEC, Article 680 is crucial to differentiate between a permanently installed swimming, wading, and therapeutic pool and a spa or hot tub to determine ground fault circuit interrupter. GFCI protection requirements. A permanently installed swimming, wading, and therapeutic pool, as defined in Article 680.2, is a structure intended to contain water to a predetermined level and that is constructed in or on the ground or in a building and designed to be installed so that the top of the pool is at or below the surrounding ground level, or so that the pool is constructed in such a manner that it cannot be readily moved or dismantled. On the other hand, a spa or hot tub, also defined in Article 680.2, is a heated structure or vessel containing water for bathing and or relaxation purposes. The key distinction lies in the permanency of the installation and whether the structure is designed to be readily moved or dismantled. Consider an outside, in-ground, custom-made installation designed to hold water with its top level below the surrounding ground level. Such an installation aligns more closely with the definition of a permanently installed swimming, wading, and therapeutic pool. Therefore, it's essential to understand the GFCI protection criteria based on this classification. For permanently installed swimming pools, the NEC stipulates that only the underwater light fixture requires GFCI protection as per Article 680.42. B. This specific requirement ensures the safety of individuals in the pool by minimizing the risk of electric shock from faulty underwater lighting. In contrast, for spas or hot tubs, the NEC mandates that all electrical equipment must be GFCI protected, as outlined in Article 680.44. This comprehensive GFCI protection is necessary due to the close proximity of electrical equipment to the water and the increased risk of electrical hazards in a spa or hot tub environment. It is important to carefully evaluate the characteristics of the installation to determine its classification accurately. Factors such as the permanent nature of the installation, its location below the surrounding ground level, and its intended use all contribute to the classification process. Given the characteristics of an installation that is permanent and located below the surrounding ground level, it is more likely to be classified as a permanently installed swimming, wading, and therapeutic pool. Therefore, GFCI protection would primarily be required for the underwater light fixture. It is always recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Correctly classifying the installation and implementing the appropriate GFCI protection measures are crucial for ensuring the safety of users and preventing electrical hazards. To further clarify the requirements, let's delve deeper into the specific sections of Article 680 of the NEC that pertain to GFCI protection for swimming pools, spas, and hot tubs. Article 680.26 covers the bonding requirements for metal parts of the pool structure and equipment. Bonding is the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. This is crucial for minimizing voltage gradients in the pool area and preventing electric shock hazard. Article 680.26. C specifically addresses the requirements for bonding of perimeter surfaces. This section mandates that all metal parts within a certain distance of the pool, such as metal fences, handrails, and other conductive elements, must be bonded together to create an equipotential bonding grid. This grid helps to equalize the electrical potential in the area surrounding the pool and further reduces the risk of electric shock. In addition to bonding, grounding is another essential safety measure for swimming pools and spas. Grounding involves connecting the electrical system to the earth, providing a lower impedance path for fault currents to flow back to the source. This helps to quickly trip circuit breakers or GFCI devices in the event of a ground fault, preventing dangerous voltages from being present on conductive surfaces. Article 680.21 specifies the requirements for grounding of pool equipment, including pumps, filters, and heaters. These devices must be grounded to ensure that any fault current is safely conducted back to the electrical panel. Furthermore, Article 680.25 It requires that all electrical equipment installed within the pool area must be provided with a grounding conductor that is connected to the equipment grounding bus in the electrical panel. This grounding conductor serves as a redundant safety measure in case of a failure of the primary grounding path. Now let's focus on the GFCI protection requirements for specific types of equipment. As mentioned earlier, Article 680.42 V mandates GFCI protection for underwater lighting fixtures in permanently installed swimming pools. This requirement applies to all underwater lights, regardless of their voltage or wattage. The GFCI device must be installed in a readily accessible location and must be rated to trip at a maximum of 5 mA of ground fault current. Article 680.43 provides additional requirements for underwater lighting fixtures, including the depth at which they must be installed and the type of wiring methods that are permitted. These requirements are designed to minimize the risk of water intrusion and electrical shock hazards. In addition to underwater lighting, GFCI protection is also required for other electrical equipment in the pool area. Article 680.22 A4 requires GFCI protection for all receptacles that are located within a certain distance of the pool. This requirement is intended to prevent the use of electrical appliances near the pool that could pose a shock hazard. The specific distance requirements vary depending on the voltage of the receptacle and the type of pool. Article 680.22 A5 further mandates GFCI protection for all electrical equipment that is used to operate or maintain the pool, such as pumps, filters, and heaters. This requirement ensures that any ground fault in these devices will be quickly detected and interrupted, preventing electrical shock hazards. For spas and hot tubs, the GFCI protection requirements are even more stringent. Article 680.44 requires that all electrical equipment associated with a spa or hot tub must be GFCI protected. This includes pumps, heaters, blowers, lighting fixtures, and any other electrical devices that are installed within the spa or hot tub enclosure. The GFCI devices must be installed in a readily accessible location and must be rated to trip at a maximum of 5 mA of ground fault current. Article 680.44 also specifies the wiring methods that are permitted for spas and hot tubs. All wiring must be installed in rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, and all connections must be made with watertight fittings. This helps to prevent water intrusion and corrosion, which can lead to electrical failures and shock hazards. In addition to the GFCI protection requirements, Article 680 also includes specific requirements for the location of electrical equipment near swimming pools, spas, and hot tubs. Article 680.21 requires that all electrical equipment be located at least 5 feet away from the inside wall of the pool, spa, or hot tub. This requirement is intended to prevent accidental contact with electrical equipment while in the water. If it is not possible to maintain a 5-foot clearance, the electrical equipment must be protected by a barrier or enclosure that prevents access by unqualified persons. Furthermore, Article 680.21 B prohibits the installation of electrical equipment directly under or within 5 feet horizontally of any diving platform, diving board, or slide. This requirement is designed to prevent electrical hazards in areas where people are likely to be jumping or diving into the water. It's important to note that the NEC is a complex and constantly evolving document. It is essential to stay up to date on the latest code requirements and to consult with a qualified electrical inspector or engineer to ensure compliance. Additionally, local codes and regulations may impose more stringent requirements than the NEC, so it's important to be aware of these local variations. Failing to comply with the NEC and local codes can result in serious penalties, including fines, project delays, and even legal action. More importantly, non-compliance can create dangerous electrical hazards that can lead to injury or death. Therefore, it's always best to err on the side of caution and to ensure that all electrical work is performed by qualified professionals who are familiar with the latest code requirements. In summary, Understanding the differences between permanently installed swimming pools and spas or hot tubs is crucial for determining the appropriate GFCI protection requirements. Permanently installed swimming pools generally require GFCI protection only for underwater lighting fixtures, while spas and hot tubs require GFCI protection for all electrical equipment. Bonding and grounding are also essential safety measures for both types of installations, and specific requirements apply to the location of electrical equipment near the water. By carefully following the NEC and local codes, and by working with qualified electrical professionals, it's possible to ensure the safety of users and to prevent electrical hazards in and around swimming pools, spas, and hot tubs. Remember to consider the specific characteristics of the installation, including its permanent nature, location, and intended use, when determining the appropriate classification and GFCI protection measures. When installing or maintaining electrical equipment near swimming pools, spas, or hot tubs, always prioritize safety and follow all applicable codes and regulations. The NEC is not just a set of rules, it's a guide to ensuring the safety of people and property. By understanding and adhering to its requirements, you can help to prevent electrical accidents and create a safer environment for everyone. Let's delve deeper into specific scenarios and examples to further illustrate the application of these principles. Firstly, consider a scenario where an individual is installing a new underwater light in an existing swimming pool. Before commencing the installation, it is paramount to disconnect the power supply to the circuit. Subsequently, the individual should verify that the new underwater light fixture is Underwriters Laboratories ALL listed and compliant with all applicable safety standards. The underwater light fixture must be installed in accordance with the manufacturer's instructions and the NEC requirements. This includes ensuring that the light is properly grounded and bonded to the pool's bonding grid. The wiring connections must be made with watertight connectors to prevent water intrusion. A GFCI device must be installed in the circuit to protect against ground faults. Upon completion of the installation, the individual should test the GFCI device to ensure that it is functioning properly. This test involves pressing the test button on the GFCI device and verifying that it trips, interrupting the power supply to the underwater light. Secondly, let's consider a scenario where an individual is installing a new hot tub on their property. Prior to the installation, the individual should obtain all necessary permits and approvals from the local authorities. The hot tub must be installed in accordance with the manufacturer's instructions and the NEC requirements. This includes ensuring that the hot tub is located at least 5 feet away from any overhead power lines. The electrical wiring to the hot tub must be installed by a qualified electrician. A dedicated circuit must be provided for the hot tub, and the circuit must be protected by a GFCI device. The hot tub must be properly bonded and grounded to ensure electrical safety. Upon completion of the installation, the electrician should test the GFCI device to ensure that it is functioning properly. This test involves pressing the test button on the GFCI device and verifying that it trips, interrupting the power supply to the hot tub. Thirdly, consider a situation where a homeowner is experiencing problems with the electrical system in their swimming pool. The homeowner should immediately disconnect the power supply to the pool and contact a qualified electrician. The electrician should inspect the electrical system to identify the source of the problem. Common problems include faulty wiring, damaged equipment, and ground faults. The electrician should repair or replace any damaged equipment and ensure that all wiring connections are secure and watertight. The electrician should test the GFCI devices to ensure that they are functioning properly. The electrician should also verify that the pool is properly bonded and grounded. By addressing these issues promptly and effectively, the electrician can help to prevent electrical hazards and ensure the safety of the pool users. In addition to these specific scenarios, it is important to be aware of some general safety tips for swimming pools, spas, and hot tubs. Never use electrical appliances near the water. Keep all electrical equipment away from the pool area. Do not swim during thunderstorms or lightning storms. Be aware of the location of the main power disconnect for the pool or hot tub. If you experience any tingling sensations while in the water, immediately exit the pool or hot tub and contact a qualified electrician. Have the electrical system inspected regularly by a qualified electrician. Teach children about electrical safety and the dangers of swimming pools, spas, and hot tubs. By following these safety tips, you can help to prevent electrical accidents and ensure a safe and enjoyable experience for everyone. In conclusion, the electrical safety of swimming pools, spas, and hot tubs is a critical concern that requires careful attention to detail. Understanding the NEC requirements, implementing appropriate GFCI protection measures, and adhering to general safety tips are all essential for preventing electrical hazards and ensuring the safety of users. Always prioritize safety and work with qualified professionals to ensure that all electrical work is performed correctly and in compliance with all applicable codes and regulations. By doing so, you can help to create a safer environment for everyone to enjoy.